everyone, welcome back to Sully's Rods and Customs. Today what we're going to do is I've purchased a cheap ass CNC laser engraver, and what I'm going to do is I'm going to assemble it and convert it over to a CNC plasma table so I can plasma cut parts and bits and pieces in the garage whenever I need to. So what you get in the box, like I mentioned, user manual, that's pretty much what it is. If you want a bit more information about it, there's the QR code right there. You can scan that on your TV. You'll find a bit more information. It's actually Viva brand. I know there's lots of cheap ass Chinese ones out there available, but this was the absolute cheapest I could find. This thing only has a table size, if it shows you can hang anywhere. This thing has a table size of about 30 centimetres by 40 centimetres, something like that. It's not very big, it's probably the size of this box, pretty much. Righto, so as you can see, I've assembled it, I've installed the software, the Viva software. Wouldn't work on my laptop for some reason. It's a brand new laptop. So I just downloaded some laser GRBL version 7.20 and I put into test mode. It's just printing a picture there now. It's just burning it into a bit of paper. As you can see, it's burning through the paper. But that's working so far. There you go, so you can see what it's actually printing down there. What it's actually printing is, it's printing that picture there. You can see the green line there where it's up to. You can see the green line there where it's up to, so it's pretty much just done. It's pretty much just printed their legs. You can see there it's printed their legs. So I guess righto. So what we've done here is we've set up the new bracket arrangement for the plasma attachment to the router, the CNC engraver. So what we've done is, and I made it work, Nick Rimmer, he pretty much copied this original bracket which held the laser on, which was this bracket here, and what he did was he used his AutoCAD skills and 3D printing skills, and he printed me this thing. So what this allows me to do is, the old laser, I'll find that here somewhere. The old laser attachment was this, and it used to bolt on to the front of this thing and sort of connect right at the front here, and it shot the laser down to the material that you're going to engrave. So that's pretty much how it used to fit together. So what he did was he extended it down. So if I want to actually mount that laser down low, I could put this on. I could take this plasma attachment off and mount it down low. So I pretty much, he made the mounting bracket for me, which this is my x-axis. My y-axis. So what he did was I drew up on here sort of the size I needed for the laser attachment, and you'll see this thing will start printing what I need it to print now. Not printing, start engraving, plasma cutting, but I've got the plasma turned off at the moment, so I'm just trying to get this thing working. So I'll turn it off just so I can finish what I was saying. I didn't mean to actually turn it on. Yes, I want to abort that. So, yeah, what it allowed me to do was, I'll just turn this camera around so I can see. That's no good. I'll turn to the back here. So what it allowed me to do was, instead of having the actual laser mounted up high here on a short mounting board, I can mount it down lower. But that plasma attachment you can see over there, let me just slew that around. I just drew that up, got him to modify it and make it for me. So see that bracket there? It just mounts onto this printed board. So this is just a plastic board at the moment, and all we're doing is just proving that the concept works. Made this mounting bracket, which is 32mm hole, which mounted my plasma torch straight in the top of it. And then like I said, I haven't got the laser attached at the moment. Here's the laser button. If I plug this into this little laser here, it'll put the laser at the end of it. I don't want to use that laser. All I want is the plasma to run. That's just crossed over at the moment. Plug that back in. So what I'll do now is I'll show you how this actually runs. I'll just bring this around over here somewhere so you can see, you'll be able to see what's on this. You'll be able to see what's on this screen here. I'll stop the job and I'll start it again. Just got to be careful. At the moment I've got nothing holding my plasma torch sort of lead wire up, so I kind of got to hold it here out of the way by hand. So at the moment you can see that job that I've got on the screen there. Just a couple of brackets I just made up myself there. I forgot to home it down there, so you'll see now it'll actually move out to its right position. It won't get jammed on things that it was getting jammed on before. There you go, it's cut those two holes out first, it's followed that path. And you can see the little cursor down here following around. So if I can get this thing working with my plasma torch, I've got to get a little catenary made for here, so this cable's out of the way. I've got a little catenaries made for the side here to hold these drag cables here. But as you can see, it'll follow the path of a bracket that I want to get made, or a double bracket, like I said, and just a plain hole in the plate. Hopefully you can see that a bit easier if I take that away. So it's saying now it's cut that, right? What I've got to do next is I've got to work out where this trigger wire goes from the laser down to my plasma torch, which is down here, my plasma cutter. It's an easy cut SIG weld. It's an easy cut 35. So what I've got to do is I've got to work out how to disconnect this end. G'day everyone, welcome back to Sully's Rods and Customs. Today I'm going to fit the Arduino GRBL controller to the little CNC plasma cutter we've made up. As I described previously, we've got a small CNC laser engraver. What we did was I took off the laser attachment and I had a bracket made up to hold my plasma torch. Fitted a small catenary to it. I'll show you that in a second. Hopefully I can get that to move over there. I'll do that in a sec. Let me just see if I can't make this fit there. There you go, there's a small CNC plasma cutter we've made up. What we did was we fitted these catenaries on here, so you can see as it runs now, the little catenary runs around with the little cable chain runs around with all the wires in it. Same on the long travel. So you can see the long travel moves back and forward here. So what I've done here is I've extended the cable from my plasma torch, or plasma cutter. This is the original plug that used to go to the laser. So when this little computer used to trigger the laser, it used to turn this on and power it up. So I'll plug that back in there. I have this plug here, which is all my limits that I have on here. So each one of these axes has a limit on it. On the X and Y axis, on the long travel or cross travel, whatever you want to call it. So this runs down to the end here. You'll hear it hit the limit. Hopefully you hear that click off. Same the other end. And now they're a hard limit. So there's a certain parameter you have to set up so this thing knows the size of the table that it's cutting, and the hard limit is there as a safety factor. So if it runs too far, it actually hits it and trips it out. So I just need to plug in all these these are the stepper motor drives. So there's 3 stepper motors on this. There's 2 long travel or Y-axis, and there's there's 1 cross or X-axis on here. So I'll just plug these into where they've got to go. Hopefully they're all the same plug. I marked them, so hopefully I've got this one marked as X. So hopefully they're all correct. Plug the limits in. Let me see, where's that hole there? So there's the limits plugged in there as well. So I use this ribbon cable. Had one of the guys I know fit the plug up to me with the ribbon cable, and then I just spliced off as much as I needed on the end of it here. I could have cut it a bit shorter, and I probably will. I'll probably cut them in and tee them in right next to the catenary or cable vey when I get some time. But for now, I've just soldered all the joints in here just to make it right. So this also has a power supply which plugs in the side here, which comes from 240 volt mains, and it has the little connector that comes from the laptop. So that's that part. I'll turn the power on. You'll see this has come on now. It's got the red light in there saying it's detecting signal from the laptop. It's got the little red power light coming up in there. Hopefully you can see that without that glare on it. Down the bottom in there. I'll just log into this laptop here. Right, logged in there, and what I'm currently using is laser GRBL, which came with this small Vivo brand laser cutter. So at the moment, what I'm going to do is I'm going to power this laser up. I'll power this machine up. I'm going to do like a test cut on it. So I'm going to load up a file here. It's just a small bracket file that I made up. So it says create, so it turns it into a G-code file, and the picture's up on the screen there. I turn on my plasma cutter. That's on. So at the moment, the plasma torch is just sitting here. So I'm not 100% sure just yet, but I think because this is a high-frequency pilot arc plasma cutter, at the moment I've disabled the trigger. At the moment, this cable here runs into the back of my plasma cutter down there, and I'll show you what I've done. It runs down. I drilled a hole in the back of the plasma cutter, put a 4-pin connector on the back of the box, and what I did was I wired in. Where is it? I wired in one of these little relays. So the signal that used to come out of this cable here, that used to go into the laser. What it does now is with it has DC active, DC plus, DC minus, DC active or neutral, and in is the actual trigger wire, which is the signal wire. So those 3 wires that you can see here, the black, the red, and the yellow. We've got red in the DC. We've got black DC minus or negative, and in is the yellow cable. So, and it's in a little inside there. It's in a little box like this, just a little 3D printed box, just to keep it away from all the other terminals and connectors in there. And it's just screwed in there, and it's got a bit of double-sided tape in the back, and it's just stuck down in there. Now this is just a 3D printed box. The reason it is so thick is it looks like this on the back, right? So it's so thick so I can keep it away from the side of the actual plasma cutter. I'm going to mount it down low like this, somewhere out of the way. And it's not near the actual plasma's arc, so it shouldn't get any interference. If it gets interference, I'm going to position it back on some sort of bracket there. So that's fired up now. Its trigger does nothing at the moment. We're going to try and set this off, and you should, let me just rehome that, rehome the CNC table. That way near the limit, and I'll set that as its 0 point. So now if I if I drive this away like this, and I hit the home button, oops, wrong button. If I hit the home button, it should run back to that same location, and it didn't. That's because I hit reset here instead. Let me just take it back over there and zero it again. All right, we'll set that as the home location. Then we'll move it away, drive it down here. Let's try that home button again. So if I hit home now, it should take it to the home position. There you can see where it's gone. So hopefully now when I start this program, when I hit play, you should see this arc start up. I'll hold my hand down here so you know I'm not pressing the button. It's not good to just let it blow an arc up into the air like this because you can burn out your tip, but I'm just doing it for the purpose of showing you before I actually mount it in there, because at the moment I've only got this on this plastic table. So let's just see what happens if I hit play here. You'll hear this thing count down. It says engraving is about to begin. Wear your safety goggles. On the engraving, I'm plasma cutting in. So you can see the plasma arc is starting. You see how it cut out now? It's cut out now because it needs that ground wire to that tip. So I'll just stop it right there. Doing the other one. It's stopped again because it's repositioning. It's doing the other cut, and it's still continuing with the cut, but it's not doing the actual cut on this torch. It's stopped the torch. So again, I need to make this work so it keeps this plasma arc on all the time. So that's my next little trick. I'm going to run a ground wire all the way up to the torch. I mean, the air's still blowing on here now because it's trying to cool it down. So I'm going to run a ground wire up to the torch. I'm going to connect it to this shroud here, and hopefully, instead of it detecting a ground off of here by touching something like this, it'll detect the ground by me grounding the wire there, and hopefully it should keep going. That's my compressor starting up there, so I'll end the video here while that runs up, so keep watching. Righto, let's give this thing a bit of a test hit, see what it does. Start from the beginning. Stay over there, Han. Stay over that side. Trip the power out. I tripped the circuit board. Okay, so I tripped the power on me. I had the plasma cutter plugged into the power board and it tripped it out, so now it's plugged straight into the mains. Let's see if I can make this resume cutting, or if I have to start again. Oops. Alright, what happened then was I stopped it, because what happened was it hit the side here and it moved the torch up away from the steel. I broke the plasma bracket here. I don't know if you can see it in there. The bracket right there snapped. I over tightened the screw, so I'm trying to hold it in position just for this test run with this cable tie holding it up. I'll see if I can send this thing home again. Home is supposed to be over here. Let's see if we can make it do it again. I mean, I've got the original cut still in the middle there. I'm going to leave them there. Let's see if we can make this thing cut once more. Start from the beginning. Alright, let's see how we go this time. That's too high. Oops, that's too high. Here we go. That looks pretty good. I'll bring the camera down, I'll show you what it actually cut. So if you have a look there, that's what it cut. They cut pretty neat. There's a bit of dross around, and you can see there's a bit of an issue there with the start-stop sequence where it starts and doesn't continue to cut past it, but I'll work that out in the programming. But as you can see, that's a $160 CNC laser engraver. I already had the plasma cutter, so if you have a plasma cutter, you don't have to pay the extra money. It's probably, I would say, maybe $3 or $4 for the limits. There's 1, 2, 3, 4 limits on there. I think on eBay I bought these cable tracks here. I bought 2 of those. They're 1 metre long. There's heaps spare, but I bought 2 of those for like $6 each. Piece of aluminium to guide it along. The same piece of aluminium. It was just a bit of offset angle, like you can see here, just a bit of unequal angle, aluminium angle. I just made a track down the side here for the cable veyor to sit in. This one sits up high, so it doesn't sag, because if you put them upside down, they do this. Yeah, cheap as chips, simple process. That was just some little bodgy thing I made up to try and make it cut. I'll see if I can pull one of those pieces out if it's not too hot, see if they come out. No, they're not too hot. There you go. This is pretty thin plate. It's probably stuff I use for, doing a bit of odd panel work on a car. But as you can see there in the picture, that's I just wrote it up as a chassis bracket, but it's not like a suspension type bracket. It's not a proper bracket. I just sort of whipped it up in 5 minutes. But you can see here, I'll show you some of the issues it's got, which I've got to work out. It's a bit hot, so as you can see here, the start and stop position for the hole was not great. The hole's not perfectly round. I've got to work that out. I think that had a lot to do with this cable, the dragging of that plasma cutter around. If I put a straight torch on it, which I'm going to work on, that'll do it. Some parts doesn't have a lot of dross and slag on the back, and some parts does, but it does actually come off quite easily. So anyway, there's two of those, and the other thing was just cut a hole, like a elliptical sort of hole in the plate, like a little piece. But yeah, that's working pretty good. I'm pretty happy with that for its first cuts. I mean, I showed you the couple of stuff-up cuts I had at the start there. I've broke the bracket for the actual plasma torch, which I'll have to get fixed up. But there you go. I'll show you next time when I fix the main brackets and I get it cutting again. I won't have all these cable ties and shit on here. But once I do that, I'll put another video up and I'll show you cutting some thicker plate, and then you'll see it cut properly. So the Viva brand, VEVOR, is a Viva brand. I think it's bed size is, I think it's like 290mm cut surface by 355. So I didn't want a big plasma cutter for now. I just wanted something simple and small. I want to be able to pick this thing up when I'm done, unplug it, hang it on the wall out of the way. When I need to cut some plate, bring it down, put it down there. It's very rare that I'll be cutting a piece on this that's bigger than 255, or is it 295 by 355 in total. So for now it'll do exactly what I need to do for I think it was like $175, and then I had a $10 eBay credit of $10. It was like $165, $20 worth of other bits and pieces, so maybe under $200 for everything I needed. Had a mate 3D print the little enclosure for the plasma controller, the Arduino, and he also printed me the brackets for, which I'll show you what they look like. Here's one he printed for me, which is a straight bracket. It bolts on in multiple positions up and down, because I don't have a Z-axis on this yet. If I get keen, I might actually put one on there and just show you how it's done. I'll just buy a cheap $40 one,
mount it on there, reposition a few things, and get that Z axis going up and down, and run a vertical torch like a machine torch on it as well. So we'll see how that goes. So for now, that's about as cheap as you'll get a CNC plasma cutter working for $165. Hope you enjoyed it. Keep watching. Sully's Rods and Customs. Hit the like button, hit the subscribe. Don't forget, if you like the Sully's Rods and Customs logo, I've got that on some merchandise now, so hit up my eBay shop and you'll be able to buy some of that stuff. All sizes, all shapes, colours, so keep a lookout for that. Thanks for watching. So this is what it looks like in light burn. You can see my logo there. It's you can see my logo there. It's sort of flipped sideways to best fit on the page. And if I click this this button at the top here, you'll see it'll bring up a play mode of what I'm going to cut. You should be able to see what it's actually doing there, right? So you'll see that's the speed that it would cut the logo. If I ran it, that's 5 times speed. Let's just see that, how it's going there. There you go, it's done the car. It's doing the Sully's part there. Now designing it's not exactly easy because you've got to design it so that the parts don't fall out when you cut them. I don't know if I've done it right yet until I get a real clean cut. You see now it's just doing the last couple of details. It's doing the outline cut. And it comes back to the start. And when it gets to there, it's finished. And at that point there, the piece should just fall out, and all these details technically should fall out of it, and it should leave an outline of what's there. But like I showed you before, the cuts we've been doing, that's what it currently looks like, right? That's the logo. See if I turn it around, you can get the right. Hopefully it doesn't make you seasick looking at it there. But that's what it looks like from above. You can see here where it chopped off the edge, where it jammed the torch on a bit of this distortion, and then the torch jumped, or the tracks jumped a couple of teeth. But you can see it's trying to cut out the pieces. These pieces are loose here. They'll all drop out. You can see down here the other one I was cutting, which is still stuck under the side of the frame here. But it was really trying to do a cut. If those bits of slag and stuff and all this distortion didn't happen, I think I'm on a winner. So those cuts are really clean. This thing does a really nice cut. I don't know if it's all about the little frame there, or if it's my actual plasma cutter. This is a, what is this? It's a SIG Weld Cut 35, I think it is. So it's not made for heavy plate. It's only made for like 10 or 12 millimeter plate. And yeah, so I think we're really on a winner with this thing. I think we're for $165 or $170 for that frame there, and a couple of teething issues. Once I get this torch sorted, I've got a I have a vertical, or what do you call it, a machine torch ready for it. So it'll be a vertical torch mounted in there. It'll get mounted in a bracket. I don't have to worry about cable management as much then. Once I get that sorted, I actually bought the wrong one. This torch is not designed for that actual plasma cutter. This is a pilot arc plasma cutter, and this one's actually has to touch metal to take the arc, and then it's supposed to raise up. But I don't have a Z axis on this thing. I just have the X and Y axis, and you can see it moves quite freely. Knows when it's going to hit a limit. You'll hear it. Hear it clicking on its limits there. Same on the X and Y axis. It'll hit the X and Y axis limits. You can see how the little catenary that holds the cables scrolls along there. And the other one on the other side I've showed you before. So simple little process, very cheap little plasma cutter. It'll do the job. It'll definitely cut what I need. I just need to work out a way to stop this distortion. And like I said, get a new bit of plate tomorrow. I have to stop at the steel store on the way home and buy something. I might even get them cut to the actual table size that I've got here. That might actually help me with my issues of distortion without it sitting on the edge. And we'll go from there. Thanks for watching.